Welcome to The Explainer. I'm so thrilled you're tuning in today because we're going to completely demystify networking basics. Whether you're prepping for that big CCNA exam, gearing up for an IT job interview, or honestly, if you just want to finally get how your computer actually talks to the rest of the world, well, you're in exactly the right place. We're going to build this up step by step.
All right, let's start right at the absolute foundation. What exactly is an IP address? Well, think about the good old postal service. If someone wants to send you a letter, they absolutely have to have your physical house address, right? Without it, your mail is just lost in the void. And your computer operates the exact same way. It needs a unique address so that other devices on the internet can actually communicate with it without the total chaos of delivering your data to someone else's machine. So here's our roadmap for today. Number 1, networks and IP basics. Number 2, understanding IPv4 classes. Number 3, public versus private IPs. 4, special reserved IPs. And finally, number 5, essential CCNA exam tips. All right, kicking things off with Section 1, networks and IP basics. The concept of a network is actually incredibly vast. At its core, a network is literally just a group of devices connected together to share data and resources. But that scales up dramatically. It goes all the way from a PAN, that's a personal area network, like your phone connecting to your smartwatch, up through your standard home LAN, all the way out to a WAN, a wide area network that spans the entire globe, and even VPNs for secure private tunneling. Now, to make all those networks actually function, we need two main things, an IP address and a protocol. The IP address is your device's unique logical identifier, and that's actually governed by a global authority called IANA, the Internet Assigned Numbers Authority. But what about the protocol part of Internet Protocol? Well, a protocol is simply the rulebook. It's the set of rules and regulations that lets computers communicate, send files, and receive data without the whole thing descending into total chaos. And this brings us to a really crucial distinction that frankly trips up a lot of beginners: MAC addresses versus IP addresses. See, your MAC address is physical. It's a 48-bit hexadecimal identifier, permanently burned right into your network interface card. It is totally one of a kind, and it never changes. But your IP address? That's logical. It can be 32-bit or 128-bit, and it actually changes depending on the network you connect to. So if you take your laptop from your house down to the local coffee shop, your MAC address comes with you, but your IP address completely changes. Which naturally leads us into the two types of IPs you're going to encounter. IPv4 is the classic standard. It's a 32-bit address broken into 4 octets, written out in a simple decimal format we can easily read, like 192.168.1.1. But because we're actually running out of those addresses, we're transitioning over to IPv6. IPv6 is a massive 128-bit address written in hexadecimal format, which basically gives us more than enough unique addresses for future generations of devices. So why the shortage in the first place? Well, just think about this massive number. Because IPv4 uses 32 bits, the absolute maximum number of unique devices we can connect is roughly 4.29 billion. Now, 4.3 billion might sound like a lot, but think about how many smartphones, laptops, smart TVs, and servers are out there in the world today. We blew right past that number, which is exactly why managing these addresses efficiently has become so absolutely critical. Moving right along to Section 2, understanding IPv4 classes. Okay, imagine looking for a single word in a dictionary that has a billion words in it, but absolutely zero alphabetical order. It would take an eternity, right? To fix this, IP addresses are organized numerically into distinct classes. Every single IP address is split into 2 parts: a network ID, which represents the network itself, and a host ID, which represents the specific device on that network. The class of the IP dictates exactly where that split happens across the 4 bytes. So the absolutely crucial point here is knowing these ranges. Class A, which spans from 0 to 126, is for massive networks with literally millions of hosts. Class B, from 128 to 191, is for your medium-sized networks. Class C, from 192 to 223, well, that's what you're usually going to see in smaller local networks. Then we have Class D, ranging from 224 to 239, which is specifically reserved for multicasting. And finally, Class E, from 240 to 254, is strictly kept for research and experimental development.
Next up is Section 3, public versus private IPs. Think of it kind of like this. Your public IP is like your company's main phone number. It gets assigned by your internet service provider. It's totally unique out there on the internet. And examples would include addresses like Google's 8.8.8.8. But a private IP, That's more like your personal extension inside the office building. It's used internally on your local network, it is not directly routable on the public internet, and it looks a lot more like the familiar 192.168.1.10 that you probably use at home.
Imagine you have a single router acting as a gateway, connecting three completely different local area networks, or LANs. What's cool is that each LAN gets its very own specific private IP range. Say LAN 1 uses the 223.1.1 network, LAN 2 uses 223.1.2, and so on. The router basically acts as the bridge between all these internal private hosts and the wide outside world. All right, on to Section 4, Special Reserved IP Addresses. Here's a really quick overview of the special reserved IPs we're about to decode. We've got loopback, API-PIA, multicast, broadcast, the network address, and the default route. These are foundational concepts you absolutely, simply have to know. First up is the loopback address, which you'll most commonly see as 127.0.0.1. Honestly, if you see this, the computer is essentially just talking to itself. It's sort of the digital equivalent of thinking out loud. It doesn't send any traffic out onto the physical network at all. Instead, you ping this address just to verify that your own local network card and your TCP/IP protocol stack are actually working properly. Now, on the flip side, if you ever check your IP and it starts with 169.254, you should consider that a huge red flag. This is an API-PA address, which stands for Automatic Private IP Addressing. Basically, Windows automatically assigns this to your machine when it tries to reach the DHCP server, which is the system that hands out IP addresses, but the server just completely fails to respond. It's your computer's way of saying, hey, we have a major network problem here. And on the complete other end of the spectrum is the broadcast address 255.255.255.255. This is a one-to-all communication method. When a PC powers on and doesn't know a single thing about the network, it uses a broadcast address to essentially yell at the top of its digital lungs to every single device on the network, asking, hey, where is the DHCP server? Which brings us to our final stop, Section 5, Essential CCNA Exam Tips.
Okay, if you're taking the exam, you need to lock these patterns into your memory. If a question asks about an IP starting with a 10, 172.16 through 31, or 192.168, boom, immediately recognize those as private IPs. If you see 127.anything, that is your loopback. If an address starts with 169.254, your DHCP has failed and it's an IPPA. And if they ask about video streaming to multiple specific receivers, zero in on that multicast range of 224 to 239. Memorizing these exact triggers is a surefire way to score points on the CCNA.
And just like that, we've reached the end of our foundational roadmap. But hey, before you go, I want to challenge you. Grab your phone or open your computer's network settings right now. Take a peek at your Wi-Fi details. What IP address are you actually using? Apply what we just talked about to your own home network. Look at your subnet mask. Who else is hiding on that network with you? And just how much data are they seeing? Food for thought, right? Thank you so much for learning with me today, and keep exploring.